So let us start with the second class of the drug, which is called ethylenediamines. So what is ethylenediamine? So this is a ethylene chain which is attached with two nitrogen group. So two amine group we can say. So that's why it is called ethylenediamine. So this ethylenediamine is characterized by presence of this nitrogen containing atom and two carbon atom chain. So this is called two carbon atom chain, and which is considered as a linking moiety between key diaryl group. This is a diaryl group and tertiary amino moiety. So this ethylene bridge is a linking moiety between diaryl group as well as the tertiary amino moieties. All compound in these series are simply diaryl ethylene diamine. Okay, so whatever the compounds are fall under these class are simply diaryl ethylene diamine except antazoline. Okay, so why antazoline is not comes under these class? Because of the terminal amine of the antazoline and a portion of the carbon chain are included as the imidazole ring system. That means whatever terminal nitrogens are there with ethylene diamine group, other ethylene diamine derivatives, in case of antazoline, these nitrogen is a part of the imidazole ring system. Okay, so that's why it is not called true diaryl ethylene diamines derivatives. So as antazoline differs significantly in its pharmacological profile, antazoline is not always classified as a ethylene uh, diamine derivative. Okay, because of its pharmacological profile is also vary, and phenbenzamine was the first clinically useful member in this class. So in ethylene diamine class, phenbenzamine was the first drug. Now let us see the structure. So this is a structure of phenbenzamine. It was the first drug in this class. So this is a ethylene chain where two amino group are there. So on one amino group, two diaryl ring are attached. One is a benzyl ring. This is a benzyl ring. This is a phenyl ring, and it's a simple dimethyl amino group. So phenbenzamine was the first uh, drug in this class. Now let us compare the structure of phenbenzamine and triplenamine. So if you look at the structure, so from structure of phenbenzamine, here there is a changes. Instead of this phenyl ring of phenbenzamine, if it is pyridine ring, then it's a structure of triplenamine. In structure of triplenamine, if we introduce fourth position methoxy group, it gives a structure of pyrilamine. It is also called as a mepyramine. So another name of pyrilamine is mepyramines. In same structure of the pyrilamine, say for example, in pyrilamine, this is a pyridine ring. If it is pyrimidine ring, then it's a structure of thonzylamine, and this is a antazoline, where if you look at here, this is a first nitrogen where diaryl group are attached, and this is a second nitrogen, and this carbon is a part of the ring system. So in antazoline, carbon and nitrogen both are the part of the imidazoline ring system. This is called imidazoline. So that's why it is not comes under, or it is not a diethyl ethylene diamine derivative. So this is a ethylene and this is a diamine groups. So here one carbon and nitrogen is a part of the ring system, hence antazoline is not comes under this derivative ethylene diamine. But between two nitrogen, two carbon chain distance is there. That's why it is fall under this class. Let us see first drug triplenamine. So let us see the IUPAC nomenclature. So 2-benzyl. So numbering start from here 1 and 2. So at second position this is a benzyl group, 2-benzyl. Then this is a second position again 1 and 2. 2-dimethyl amino ethyl. So this is a 2-dimethyl amino ethyl. Again this is a amino group. That's why it is called amino, and final pyridine. citrate. So by these way you can nomenclate the triplenamine. Same way pyrilamine, it is also called mepyramines. So again, this is the second positions. On second position, 4-methoxybenzyl group. So this is called 4-methoxybenzyl group. Then again 2-dimethylamino. This is a 2-dimethylamino ethyl. That means this ethyl chain. And finally amino pyridine. So by these way you can give a nomenclature to the structures. And if you look at the structure of pyrilamine differs structurally from the triplenamine by having a 4-methoxy group at para position of the benzyl radical. And these pyrilamine differ from its more toxic and less potent precursor phenbenzamine by having a 2-pyridyl group on the nitrogen atom in place of the phenyl ring. So if you look at the structure of the phenbenzamine, so in phenbenzamine here there is a phenyl ring, while in case of the pyrilamine and in case of the triplenamine, here there is a pyridine, 2-pyridyl ring system. So it is a difference between phenbenzamine as well as the pyrilamine. And in pyrilamine and triplenamine, here there is at fourth position of the triplenamine, if methoxy group is introduced, then it's a structure of the pyrilamine, and it is also called as a mepyramine, that you have to remember. Next is a methapyrilene hydrochlorides. So in methapyrilene hydrochloride, instead of the benzyl group, thiophene group which is attached with the methylene group. So let us see the IUPAC nomenclature. Again, this is a second position. This is again second position. So second position 2-dimethylamino. This is the dimethylamino ethyl. Then this group is called 2-thionyl arnino. So this whole group is called 2-thionyl arnino. When CH2 group attached with nitrogen, and this is a thiophene ring system. So it is called 2-thionyl arnino. And last is a pyridine monohydrochloride. So in these methapyrilene, thiophene ring is considered as a isosteric with the benzene ring. So whatever the benzene ring that is present in structure of the pyrilamine, which is called mepyramine, and in triplenamine, so here this phenyl ring is replaced by the thiophene ring, which is called isosteric replacements. And isoster, that means it exhibit a similar activity. If we replace the same isosteric molecule with same isosteric molecules, its activity would be retained, it is not changed. So it is called isosteric replacements. But unfortunately in 1979 in US FD it was withdrawn due to it having a carcinogenic potency. Next is Thonzylamine. In Thonzylamine, here there is a pyrimidine ring system is there. So IUPAC is the same like previous one, 2-dimethylamino. That means this is a 2-dimethylamino, then ethyl. This is a ethyl para position. There is a methoxy group. So para methoxy. This is whole as a benzyl group. So para methoxy benzyl. This nitrogen is a amino group. So amino pyrimidine, that means this is a pyrimidine. So again I am repeating, let us start with the 2. So this is a 1 and second position, that's why here it's a 2. Again 1 and 2 position, 2-dimethylamino ethyl. So 2-dimethylamino ethyl. Para position methoxy group, para methoxy benzyl, this is whole as a benzyl. Then last is amino, and this ring is called pyrimidine. So pyrimidine ring present in thonzylamine. Last is antazoline. So in antazoline, basic ring present is imidazoline. Okay, start with the 2, then N benzyl anilino. So this is whole is called benzyl anilino methyl. This is a methyl group, and then 2-imidazoline. So number start from here, and this is second number, 2-imidazoline. So this is the structure of the antazoline. So where imidazoline ring is present, and this is called benzyl group, and this whole group is called anilino. So this diaryl ring system with nitrogen atom, which is called benzyl anilino group. And antazoline, like ethylene diamine, contain an benzyl anilino group linked to a basic nitrogen through 2 carbon chain. Okay, same like this benzyl anilino group, which is attached by 2 carbon chain, and this both the carbon attached with the terminal amino group. So it is the same kind of structure like ethylene diamine group. So this is a third class of the H1 receptor antagonist, which is called Piperazine. We can also say it is a cyclizines. Okay. Now what is Piperazine or what is cyclizine? It can also consider as a ethylene diamine derivatives. Okay. But it is a cyclic ethylene diamine derivative. That's why it is called cyclizine. So why it is called cyclic ethylene diamine derivative? So like ethylene diamine, two nitrogen are there, and in between these two nitrogen ethylene chain is there. So that's why it is called cyclic ethylene diamine derivative. And this is the structures of the piperazine. This six member ring containing a 1 and 4th position nitrogen, which is called piperazine ring system. And another way it is called cyclizine because it is a cyclic ethylene diamine derivative. So uh, friends, these are the various structures. So this is the first structure of cyclizine, where two one phenyl ring, one benzyl ring attached at the 4th position of the nitrogen, and this is the first position of the nitrogen, or you can say first amine group, and this is a 4th amine group of the piperazine ring. So in structure of cyclizine, here if we introduce the chlorine, then it's a structure of the chlorocyclizine. In structure of the chlorocyclizine, instead of this methyl group, metazylene group is introduced, then it is a structure of the Meclizine. And in structure of the Meclizine, if this metazylene group is replaced by para tert butyl benzyl group, then it's a structure of the Buclizine. So how you can remember this structure? So Bu for tert butyl group. So whenever the tert butyl group present at the first position of the nitrogen, then it's a structure of the Buclizine. Meclizine, that means metazylene or simple methyl groups are there. So two methyl groups are there. One is a methylene, another is a methyl group. So meta-methyl group is attached, then it's a structure of the Meclizine. When chloro at 4th position of the benzyl ring, then it's a chlorcyclizine, and in cyclizine it's a simple diarrhea derivatives. So these all are the structures of the cyclizine derivative. Let us discuss one by one. This is the structures and IUPAC nomenclature of the cyclizine hydrochlorides. So let us start with diphenyl methyl. That means this is a diphenyl and methyl and one positions. Then this is a fourth position there is a methyl group. So 4-methyl piperazine monohydrochloride. This is a nomenclature of the cyclizine. In chlorcyclizine, so first positions, this is the first positions, parachloro, that means this parachloro, and this is also called alpha positions, alpha phenyl, and whole is a benzyl group, benzyl. Again 4th position there is a methyl group, 4-methyl piperazine. So by these way you can give a nomenclature to chlorocyclizine, and the difference between cyclizine and chlorocyclizines are in structures of the cyclizine at 4th position. If it is introduced chlorine, then it gives a structure of the chlorocyclizine. Now suppose here on these ring system, phenyl ring system, disubstitutions or substitution of the halogen and second and third positions. That means ortho and meta position, if there is a halogen is substituted, then result in the less potent compound. So this fourth chloro group is required for activity, we can say. Next is the Meclizine. So let us understand the IUPAC nomenclatures. So this is again first position or first nitrogen where parachloro is there. So this is called parachloro. This is alpha positions. This is a phenyl ring and this whole is a benzyl. So that's why it is called alpha phenyl benzyl. This is a fourth positions and this is a meta position or you can say third position. So meta methyl benzyl. So this whole is called meta methyl benzyl and last is a piperazine. So Meclizine is preliminary use as an anti-nauseant in the preventions and treatment of the motion sickness and another use in treatment of the nausea and vomiting associated with the vertigo. So these are the important uses of the Meclizine. Next is a Buclizine. So let us understand the nomenclatures. So here first number is given to here. So para positions, there is a tert butyl group. So para tert butyl, this whole is a benzyl group. So then benzyl. Then this is a fourth positions. Para chloro, this is called alpha positions, alpha phenyl benzyl. So this is alpha phenyl group and whole is a benzyl group and last is a piperazine dihydrochloride. So this is the structure of the buclizines. In structure of buclizine, para-tert butyl benzyl group is attached at N1 position. Fourth number of the class is propylamine or you can say monoaminopropyl or alkylamine derivative. So why it is called propylamine? So propyl, as you know, that 3 carbon chain. So this is a 3 carbon chain. When it is attached with the nitrogen, then it's called propylamine derivative. So basically there are two class. One is a saturated propylamine derivative and unsaturated propylamine derivative. So let us discuss the saturated propylamine derivatives. So when propylamine with saturated carbon containing moiety are called phenidamines. Okay. So what is phenidamine chemically? When these propylamine with saturated carbon containing moiety. So this is called saturated carbon containing moiety. So this is called phenidamines. So phenidamine basically consists of the phenyl group, 2-pyridyl aryl group and terminal dimethyl amino group. So once in phenidamine this moiety is phenyl, AR dash moiety it would be a 2-pyridyl aryl group and terminal nitrogen it should be a dimethyl amino group, then it is called phenyramine and these compound differ only at the para positions. Okay, so in phenyramine where fourth position is a hydrogen or you can say unsubstituted, when chloro is there on phenyl ring it is called chlorphenyramine, bromo is there it is called bromephenyramine and these halogenated phenyramine are significantly more potent, that means 20 to 50 times more potent as well as the longer duration of action than phenyramine. So whatever the chlorphenyramine and bromephenyramine are there, which is 20 to 50 times more potent and longer duration of action than phenyramine, and all phenyramines are chiral molecule, very important for competitive examinations. All phenyramine are chiral molecules and S isomer is 200 to 1000 times higher H1 receptor binding affinity compared to R stereoisomers. Okay, so important point is phenyramines. What is phenyramines? So it is nothing but when diaryl group attach with the propyl side chain and it is a saturated derivatives. All phenyramines are chiral molecule and S stereoisomer are 200 to 1000 times more H1 receptor binding affinity compared to R stereoisomers. So let us discuss the structure. So this is a structure of the phenyramine. So as we discussed, one is a pyridyl, 2-pyridyl group, another is a phenyl ring. Same way, if fourth position of this phenyl ring attached with the chlorine, then it's a structure of chlorphenyramine. And in chlorphenyramine, its dextroisomer is clinically more potent. This is a bromephenyramine and same way dextroisomer of the brompheniramine is more active. So it's a very simple structures. If you remember the structure of pheniramine, then you can draw the structure of chlorpheniramine as well as the brompheniramine. So only there is a change at the fourth position of the phenyl ring. Now these all are the structures: chlorpheniramine, pheniramine and brompheniramine. Propylamine with saturated analog. If you look at here, this is a saturated chain where it is attached with the amine group. But in case of another example, propylamine with unsaturated containing moiety. So these all are simple open chain alkene derivative. Examples are pyrobutamine and triprolidine. So if you look at the structure of the triprolidine, where 1, 2 and 3 carbon, where first and second carbon are doubly bonded carbon, so that's why it is called unsaturated connecting moiety with the nitrogen, where nitrogen is a part of the ring system. In previous example, dimethylamino group are there, while in this unsaturated connecting moiety with propylamine, where nitrogen is a part of the ring system and the ring present in both the structure is pyrrolidine ring system. Another kind of propylamine with unsaturated system, but this is a simple open chain compound like pyrobutamine and triprolidine. But cyclic analog contain propylamine with unsaturated connecting moiety. The drugs are dimethindane and phenindamines. And this open chain propylamine, where coplanar aromatic double bond systems appear to be important factor for antihistaminic activity. That means this double bond and this aromatic system, it should be a coplanar for important antihistaminic activities, and these compounds are asymmetric in nature and E isomers are significantly more potent than Z isomers. So E isomer, that means, so what do you mean by E isomer? Say for example, these group and these group. So when these two group are opposite to each other, two bulky groups are opposite to each other, then it is called E isomers. And E isomers of all these drugs are significantly more potent than Z isomer, where pyrrolidino group of these compound is a side chain tertiary amine that is impart the greatest antihistaminic activity. So if you look at these nitrogen, which is a part of the pyrrolidine ring, which is a tertiary in nature, and these tertiary nitrogens in ring system that impart the greatest antihistaminic activity. And due to conformational rigidity of cyclic alkene propylamine has provided a useful model to determine the distance between key diaryl and tertiary pharmacophoric moiety in H1 antagonist, and distance is 5 to 6 angstrom, which is required for binding affinity, and ultimately that gives a pharmacological properties. So due to this double bond which is attached with the biphenyl system, that will produce the conformational rigidity, and due to that the distance between diaryl group as well as the terminal tertiary nitrogen pharmacophoric moiety, that is 5 to 6 angstrom, and which is required for activity. So these are the structures. First is a triprolidine, second is a pyrobutamine. In both the drug, pyrrolidine ring is present, and here it's a simple open chain alkene derivative, while this is called 1, 2 and 3. So they double bond that is a part of the ring system, so which is called closed ring system contain propylamine derivative. Here again, this is a part of the ring system, so carbon 1, 2 and 3 carbon. So again it's a propyl is there, but carbons and nitrogen are the part of the ring system. Example are phenindamine as well as the dimethindane malate. So this is called indane moiety. This is also called indane moiety. So dimethindane and phenindamines. So let us understand the IUPAC nomenclature of the phenramines. So phenyramine and chlorphenyramine. So only there is a difference at fourth positions. And in chlorphenyramine, its dextroisomer is clinically more active. So IUPAC nomenclature again in phenidamine number 1 and number 2, 2-dimethyl aminoethyl. So this is called 2-dimethyl aminoethyl. Then benzyl. So this whole group is called benzyl, and last is a pyridine. So this drug is least potent member of the series, and this is marked as a racemate. And this is IUPAC nomenclature of the chlorphenidamine. So only there is a change at para-chloro positions. And chlorination of the phenidamine at para position of the phenyl ring increase the potency tenfold with no appreciable change in the toxicity, and most of the antihistaminic activity reside with the dextroisomer. So as I said that dextroisomer of the chlorphenidamine and dextroisomer of the bromphenidamine, which is called dexbromophenidamine, which is clinically more active. Okay, and if chlorinations are done at the para position of the phenyl ring, that will increase the potency up to tenfold with no appreciable change in toxicity. This is the structure of the pyrobutamines. So you can give a nomenclature which is start from here. So this is 1, 2, 3 and fourth number of the carbon. On fourth position there is a chloro, so 4-chlorophenyl. So this is a 4-chlorophenyl. This is a fourth position, so that means this is a fourth position and this is a first position. So on third number of the carbon there is a phenyl ring, so 3-phenyl, 2-butynyl, because of 1 and 2 position double bond is start, so 2-butynyl, and last is pyroledine. By these way you can give a nomenclature to the structures. This is a triprolidine hydrochlorides, and its antihistaminic activity is confined mainly due to the geometrical isomers. So these E and Z both are called the geometrical isomers. So E means antazanine, Z means jusaman. The meaning of E is two bulky group are opposite to each other, and Z means two bulky group are in single plane, which is called Z isomers. So antihistaminic activity of triprolidine is due to the geometrical isomer in which pyrrolidine methyl group is trans to the 2-pyridyl group. So this is called pyrrolidine methyl group, which is trans to the 2-pyridyl group. So both are in transposition of each other. So hence it is called the E isomer. And as we discussed in earlier, E isomer in this uh, unsaturated propylamine derivative, which is more active compared to Z1. Next is a phenindamine. So as I said that this is a indent ring systems, and in nomenclature 2, 3, 4, 9. So this is 1, 2, 3, 4, 5, 6, 7, 8, and this is a ninth position. So all are saturated tetrahydro. 2-methyl, 9 position there is a phenyl, 9-phenyl, 1H. So this is a 1H, sorry, indeno 2,1C pyridine by tartrate. So why pyridine is written here? Because of here we have mentioned 2, 3, 4 tetrahydro. Here we already mentioned with tetrahydro. So hence you can also write down the pyridine. This is dimethindane. So again it's a indent nucleus, and this is the indent nucleus, and the drug name is dimeth indent derivatives. So where this propyl chain, which is a part of the ring system, which is attached with the amine group. So this is called closed unsaturated propylamine derivative, where example of dimethindane as well as the phenindamines, and this triprolidine and pyrobutamines are the open chain unsaturated propylamine derivatives. Next class is phenothiazine. So this is the structures of the phenothiazine. So where 9 and 10 positions are heteroatom. On 9th position there is a sulfur. On 10th position there is a nitrogen. And with nitrogen, branch carbon chains with tertiary amines group are attached. And these all are the metabolism route, mono as well as the di and dealkylations. So from here there is a removal of the carbon chains, sulfur oxidation which is converted into the sulfoxides, and aromatic oxidations of the at third position to yield a phenol as well as the and oxidations. So basically phenothiazine having a two main application. One is an antipsychotic compound, another is an antihistaminic compound. So in antihistaminic, where these carbon chains are branch carbon chain, so if it is a branch propyl chain, then it gives a antihistaminic activity. If it's a straight chain like propyl or without branching unbranched propyl chain, it gives an antipsychotic activity. So these point you have to remember for various competitive examinations. Phenothiazine with unbranched propyl chain, which is having antipsychotic activity, and phenothiazine with branch propyl chain, which are having a antihistaminic activity. So these are various example: promethazine, trimeprazine, and methdilazines. So here if you look at here, propyl chain is there which is attached with dimethylamino. Here substituted propyl chain is there which is attached with dimethylamino. And here again 1, 2 and 3 propylamine is there, but it is a part of the ring system. So which is called methdilazine. Next is a, let us understand the IUPAC nomenclature of the promethazine. So as I said that this is a 1, 2, 3, 4, 5, 6, 7 and 8 position. This is a 9 position and this is a 10th positions. So on 10th positions 1 and 2 positions dimethylamino group is there. So 10 2 dimethylamino, and this whole chain is considered as a propyl chain, propyl, and whole molecule is phenothiazine. Next is a trimeprazines. So again 10 third position, this is a 1, 2 and third position dimethylamino, second position methyl group, and whole chain is a propyl phenothiazine, and it has a antipruretics action also. Next is a methdilazines. So again 10th position, this is a first position 1 methyl, and 1, 2 and third position there is a substitution. So this is a 3 pyrodiniles. This is a methyl group and whole is phenothiazine. By these way you can give a nomenclature to the medicinal agents. And last class in classical antihistaminic agent is dibenzocyclohaptenes and dibenzocyclohaptanes. So here haptenes and haptanes, that means this is a alkane derivative, this is a alkene derivative. So this kind of dibenzocyclohaptene and haptanes, it is also regarded as a phenothiazine analog. So if you look at the structure, this is a dibenzocyclohaptene, this is a dibenzocyclohaptane, and this is a phenothiazine, where sulfur of the phenothiazine is replaced by the here ethylene side chain, or you can say 2 carbon chain, where sulfur atom has been replaced by the isosteric vinyl group in case of the cyproheptadine. So this is a structure of the cyproheptadine where vinyl group is there, and saturated ethyl bridge which is present in the azatidine, and the ring nitrogen has been replaced by the sp2 carbon atoms. So that means whatever nitrogen is there in case of the phenothiazine, which is replaced by the sp2 hybridized atom. So this is a basic difference between dibenzocyclohaptene and dibenzocyclohaptane derivatives. So the two members of these series are closely related into the structure. So say for example azatidine. So if you look at the structure of the cyproheptadine, where second position there is a no any heterocycle is there, but in azatidine heterocycle atom is there. In structure of cyproheptadine, here there is a double bond, it's a vinyl group, here saturated ethyl bridge is there. So azatidine is a aza isoster of the cyproheptadine, and in which 10 and 11 double bond is reduced, and these agents are potent antihistamines with moderate sedations as well as the anticholinergic and lethal antiemetic activities. So this is a structure of the cyproheptadine, and cyproheptadine possesses both antihistaminic as well as the anti-serotonin activity as well as the antipruritic activity. And this drug is used as a off-label for nightmares associated with post-traumatic stress disorder. This is called PTSD as a off-label drug. Also used in preventions of the migraines, suppression of the vascular headache as well as the appetite stimulations. And sedation is a most prominent side effect of this drug, and this is usually disappearing after 3 to 4 days of the treatments. Next is a azatidine maleate. So it is a potent long-acting antihistaminic with anti-serotonin activity. So this is the structures of the